Hello, everyone. Thank you for coming to the third session of TMACOG's Water and Wastewater Operator Trainings for 2021. I'd like to start off by providing a brief overview of how we're going to go through the session today, and then some of the things that we'll have to do in order to make sure that everyone can get their operator credit hours. So the first thing I'll start off my name is Matt Kennedy, and I'm a water quality planner here at TMACOG. I'm joined by two other TMACOG water quality staff, Eric Kubacki and Sarah Geyer. Eric and Sarah will be administering the polls and taking your questions for the speakers. I'd also like to give a big thank you to Jones and Henry Engineers for sponsorship once again of this year's webinar series, and our presenters for their time in preparing this valuable training. Today's agenda will include presentations on understanding the final lead and copper rule revisions by Gwen Kubacki of Arcadis, and an overview of the Carey, Ohio wastewater treatment plant improvements by Peter Latta of Jones and Henry Engineers. Before we get started, I'd like to provide a brief overview of the webinar's format. The way today's going to work is that after this introduction, we will have before we get started, just want to provide a short overview of the webinar format. All attendees will be muted, but we encourage everyone to participate in discussion using the question function. You'll be able to find this webinar tooltip in the webinar tooltip box, where they will be monitored by a TMACOG staff member. Questions not answered during the webinar will be addressed afterwards. I'd like to highly encourage everyone to use that function, especially with these online type of trainings. It's a little hard to get kind of that personal interactions. We really recommend that you put those in so that we can get some really good engagement with our presenters today. You'll be asked to participate in a total of 6 polls during this webinar. It's important that you participate in these polls because they help our presenters to get to know you, and they count towards your webinar participation score. More on this score in a minute. You'll be asked to participate in a survey at the end of the presentation. This is a mandatory component of the participation score as well. Now, Eric will be launching a test poll so that you have an opportunity to try it out before the presentation begins.
So we'll just go ahead and read the poll questions. What best fits your position? Operator, engineer, administrator, or other?
And just so everyone knows, as we're working through these polls as they come up in the presentations, we'll be addressing some questions during that time so that we are able to not have any kind of downtime, and we can use this as effectively as possible to really get as much information across as we can. So feel free to use that time to put in questions in the question box, and we can use that to have additional time to be able to get some more things answered. So now that that poll is finished up, Eric, if you want to read off the results that we had.
It looks like we have a good selection here. We have 48% operators, 29% are engineers, 10% administration, and 14% other.
It's great to hear that we have a good mix today to be able to really provide as much information as we can. We like to reach as broad of an audience as we're able to. As I'd mentioned earlier, that we will have specific things that are required in order to be able to track the participation and make sure that everyone can get their contact hours. Today's webinar has been approved for 2 Ohio EPA credit hours, 1 for wastewater and 1 for drinking water. To provide operator contact hours, the OEPA requires us to monitor attendance and participation. For the first part of this, in order to receive the contact hours, you need to have the webinar as your active screen for at least 90% of the time during the event. In this, I would highly recommend that everyone would close out any other apps or windows during the webinar so that you're not having any potential issues that would come up with that participation score. So I definitely recommend having the webinar screen as the only thing that you have so that you won't have to worry about any potential issues with that participation score. As I mentioned earlier, so we will have 3 polls within each presentation, and you'll need to answer 2 of 3 of those in order to be able to have that count. However, your answers will not be graded, and accuracy does not count towards your participation score. Immediately following the webinar and before you log out, you'll be requested to take a mandatory survey. The survey also counts towards your participation score. Any technology issues, such as loss of Wi-Fi, will not change these participation score requirements. So if you were to lose connection, please try to reconnect as soon as possible. Today's webinar will include 2 presentations with a 5-minute break in between. And during the break, please do not log out of the webinar and make sure to keep the webinar as your primary window screen, as it can potentially impact your score if you were to click into something else during that time. I'd also like to mention that there is in order to receive the contact hours, we have a contact hour request form through TMACOG that can currently be found in the handout section on the webinar tooltip bar. And also, if you're to contact TMACOG staff after the event, we can also provide that. But I would highly recommend everyone downloading that out of the handout section so that you'll have that on your computer ready to go to be able to fill out. Now, with those announcements out of the way, I'd like to introduce you to our first speaker. Gwen Kubacki is a registered professional environmental engineer at Arcadis with 8 years of experience in drinking water quality, regulatory compliance, and treatment system design. She holds a bachelor's degree and master's degree in environmental engineering from the University of Florida and the University of Michigan, respectively. She is currently the Deputy Project Manager for the Comprehensive Corrosion Control Optimization Project for the Great Lakes Water Authority. And with that, I will transfer over to Gwen for her presentation. Gwen, it looks like you are currently muted.
All right, thank you.
There you go, we can hear you now.
Is everyone seeing the presentation as well?
Yep.
Okay, great. See if I can put this down. All right. So as Matt said, we're going to be going over the final lead and copper rule revisions, what the public water systems need to know during this presentation. If you have any questions, please continue to put those through and I'll address them as we go through. Matt went through my background here. I'm an environmental engineer with Arcadis. I've been at it about 8 years. I also worked on the Flint distribution system optimization project following the Flint water crisis in 2015 and 2016. Where we conducted a pipe loop system. So I've been working on this corrosion control business for quite a while. And interesting to get into the new rule and how it will impact systems. So I am going to be using some acronyms through these slides. I'm going to go through a couple of the more important ones here. The AL is the action level that will be on several slides, and then jumping down to the TL, that is the trigger level. CCS will stand for corrosion control study. CCT is corrosion control treatment. The LCR is the original lead and copper rule, and LCRR is the copper rule revisions that were recently published this year. LSL is lead service line. LSLR is lead service line replacement. And some of these smaller ones will be defined as they appear on the slides. So I'll note that there is a lot in the new rule. This is a very large rule and there's a lot of changes. So I'm not going to be able to cover everything and every possible scenario that the rule goes over, but I'm going to cover the most significant items and the early action items that will impact your system. So just going over the learning objectives for this presentation. By the end of this presentation, you should be able to explain the overall objectives of the final lead and copper rule revisions, describe the key requirements of the revisions and associated compliance schedule, recognize where additional clarification or guidance on the LCRR is needed, identify actions water systems can take to achieve compliance with the lead and copper rule revisions. So our agenda today largely follows those objectives. I'll start out with the overview of the lead and copper rule and the final revisions. And we'll go through key requirements of those revisions and the major changes that are going to be the most impactful for the systems. And then we'll close with some final thoughts. So jumping into the overview, Going back to the original lead and copper rule, this was established in 1991 to protect public health by minimizing lead and copper levels in drinking water, largely through reducing corrosion and leaching of these metals from service lines and premise or household plumbing. Instead of establishing a maximum contaminant level, or MCL, which is what we see for a lot of other contaminants, EPA established action levels of 15 parts per billion, or 0.15 milligrams per liter, for lead and 1.3 milligrams per liter for copper. Compliance with this action level is based on the 90th percentile of all first draw samples, which the water system is responsible for collecting from customers' homes during each monitoring period. While an action level exceedance is not a violation of the rule, it can trigger any of the following, including additional monitoring and or treatment, public education, and where the lead specifically action level is exceeded, it can trigger lead service line replacement requirements. Since the rule promulgation, we have come a long way in reducing lead and copper in drinking water in general. As you can see, we've got an example here from Massachusetts Water Resource Authority's data from their website. And that shows the lead reduction levels over time as we've implemented this rule with the increased sampling and the treatment. So in the industry, we have made good progress, but we recognize that there were some significant implementation issues with this rule as it was promulgated in the 90s. And there's definitely room for improvement, both for improving public health and for being easier for the utilities. So it's been a really long road to get to the revisions. Really starting in 2004, there's been a national focus since the EPA decided to assess lead levels across the country following the detection of lead levels in Washington, D.C.'s system. All of you remember that, but before Flint, there was Washington, D.C., and that was a very big crisis with the lead in the water as well. Since then, we've gone through many stakeholder processes and additional analysis to better understand how we can improve this rule. So now the revisions are finally here. They're officially released in the Federal Register on January 15th of this year. I will say that there's some uncertainty around the current administration. They did pull back the rule for additional review. I shouldn't say they didn't pull back the rule, but they are opening a comment period and doing some additional review. So some of the implementation dates are not completely clear right now. We'll go through that on the next couple of slides. I'll show what we're anticipating based on the dates that have been published. And regardless, it's not expected that the rule will be pulled back and reverted to the original rule. So I do want to stress that there's a lot in this rule. There's a lot to get started on. So don't wait to get started on the implementation of some of these things. So going back to the overall objectives of why the EPA updated this rule, they wanted to improve public health through a more proactive and holistic approach, focusing on earlier action to reduce risks, largely around lead in drinking water versus the copper. In addition, the revisions do improve transparency and communication to better protect children and families and give them the materials to better protect themselves from the risks. The rule includes several new items and significant modifications to largely all of the main components of the rule, with the exception maybe of the source water monitoring and treatment. So we'll be talking through those as we go through the presentation today. So the rule established a timeline shown here for implementation and compliance. Again, I want to note that the current administration has delayed the implementation of this rule. They're taking an additional public comment on the rule and extending it at least until December 16. So based on this December 16 date that we're aware of, I've pushed back these other dates for implementation. Now, these are anticipated, the September 16, January 1, and July 1, especially the January 1 and the July 1, 2025, could potentially even be earlier. I've got the original dates in the rule for July 1, 2024 here on the first 6-month TAP monitoring period. So this is what we're anticipating, but we're awaiting the final word on that. So based on this timeline, we're anticipating that by September 16 of 2024, systems will need to have developed their lead service line inventory and replacement plan, prepare for the new trigger level and Tier 1 notification requirements, begin delivering lead service line notifications, as well as conducting find and fix assessments and school and childcare monitoring. And shortly after that, we're anticipating by January of 2025, systems will have to identify their appropriate sample locations, update their sample plans, and have trained staff ready to go with a brand new sampling protocol and sampling where lead service lines are present. So all of this to do within the next 3 years or so. So we definitely want to get started. So now I'll jump into some of the new requirements with the rule. The final lead and copper rule did maintain the current maximum contaminant level goal of 0 for lead. Again, that's different from the maximum contaminant level that you might be familiar with some other contaminants or the action level. The maximum contaminant level goal, so what we're aiming for is 0 for lead. It's also maintaining the current action level of the 15 parts per billion, but it requires a more comprehensive response if the action level is exceeded. And it also introduces a trigger level of 10 parts per billion that wasn't in the previous rule. You can see that on this slide here. That trigger level is designed to compel systems to take more progressive actions before exceeding the action level. It can include more tap sampling, optimization or re-optimization of corrosion control treatment, full lead service line replacement based on predetermined goal rate, an annual notification to your customers about your lead service line replacement program, and opportunities to replace their lead service line. We'll talk about those in more detail as we move through the presentation as well. Another big change is around notification. So given that there can be adverse health effects as a result of even short-term exposure to lead, EPA has changed 2 components. First, exceedance of the lead action level now triggers a Tier 1 public notice. So all systems must provide notice to all persons served by the system within 24 hours. So similar to an E. coli situation or other acute health risk. This is a little bit of a challenging message to communicate to the general public. The exceedance is not based on a single value, right? It's based on the 90th percentile, and 15 parts per billion is not necessarily a health-based level. So there will be some samples potentially above that level that were collected earlier in the monitoring period. So to kind of close that gap, EPA is doing 2 things. First, the notification has to be performed within 24 hours of receiving and calculating your 90th percentile lead level. So as soon as practicable, after you collect your data and calculate the 90th percentile, that's when that has to go out, not necessarily at the end of the monitoring period. Second, you must notify persons served by that tap sampled as soon as practical, but no later than 3 days if the result is above the 15 parts per billion action level, and give them information so that they can take action to reduce their risks. These are really short turnaround times on notification, so it's recommended that systems prepare in advance, including having notification templates complete and deciding how you're going to distribute the materials if needed. While exceeding the trigger level or the action level, again, is not a violation of the rule, it does trigger more action, and not completing the notification or those actions is a violation. So it's really important to be prepared to be able to get these things out if you find yourself in that situation. Another new item which was included in the draft rule, but has been clarified a little bit in this final rule, is the find and fix clause. So for any compliant sample that results in lead above 15 parts per billion, systems would need to first conduct a corrosion control treatment assessment to understand if changes in the system are necessary. They would do this by focusing on water quality parameter monitoring. So you're going to have to go out and sample water quality parameters within 5 days. That time is extended to 14 days for small systems without existing corrosion control treatment in place. The sampling has to be completed within a half mile in the same pressure zone and on the same size main or smaller as the original sample that exceeded the action level. So pretty strict instructions around this. If you already have a sample site that meets this criteria, you can use that. If you don't, you have to add a new site to your water quality parameter sampling pool until you reach up to 2 times the standard number of water quality parameter sites. The other piece of the assessment is conducting a site assessment to identify the lead source specifically at the home. So why is that house in particular exceeding the action level? So within 30 days, you have to go back and collect a follow-up lead tap sample. This does not have to be the first draw protocols. You are allowed to use alternate protocols here. It doesn't have to be that first liter compliance sample. If you're unable to sample, the system would be required to document at least 2 attempts if the homeowner is non-responsive and the reason that you weren't able to contact them. And document that and submit it to the state. Once you've conducted those assessments, if the source is within your control, you need to take action. And those actions could include flushing or adjusting your corrosion control treatment, so adjusting your orthophosphate level or a pH adjustment at the plant. If you find, however, that it's due to a source at the site or you're not able to determine the source, systems are not required to recommend additional action. But you do need to report the cause and the action to the state within 6 months of the end of the tap sampling period for any individual sample above 15 parts per billion. So if you have a monitoring round and you have 3 houses above the 15 parts per billion, this is quite a bit of work that you'll need to be prepared for. The last new component for all systems that could have significant financial impact is around schools and childcare facilities. So all community water systems must develop a list of schools and licensed childcare facilities by the compliance date, which again, we're anticipating to be September 16 of 2024. I'll note that licensing varies by state for childcare facilities, so you'll need to understand what that means in Ohio, if that includes in-home daycares or if it's just larger centers. After that point, you must provide annual education to the entire list of schools about the health risks of lead, information about the sampling program for schools and daycare centers, and instructions for sampling, as well as the 3 T's school kit. You can see the cover of this. This is a publication from the EPA that you can provide right here on the slide. And then within the first cycle, which is the first 5 years after the compliance date, community water systems will have to collect lead samples at 20% of elementary schools, and that's 5 samples per school, as well as 20% of licensed childcare facilities, and that's 2 samples per childcare facility. That's not 20% per year, that's 20% over the first 5 years. So if you have to document the facilities that do not respond or decline participation, and while you're not required to sample at the secondary schools, if they do request you to sample, then that is required. After that 5-year cycle, systems are required to conduct sampling only upon request for all elementary and secondary schools and childcare facilities. So after that first 5-year cycle, then that requirement is complete. I also want to note that the water system, school or childcare facility or other trained individuals can collect these samples. So it doesn't have to be your staff that are going into these facilities to conduct the sampling. And now we're going to shift gears a little bit and talk about the lead service line inventory and replacement requirements of the new rule. So I'm going to start with some definitions. We have an infographic here from the Lead Service Line Collaborative, which illustrates a typical components of a service line, which bring water from the distribution water main into the house. So starting on the left underneath the street, we have the distribution water main. The corporation stop is directly attached to the main, which allows systems to install the service line while the main is under pressure. Some systems may have a little gooseneck or pigtail or connector, and I'm typically going to be referring to these as goosenecks, which is a short section of flexible pipe. Often this is lead because those are easy to bend and easy to connect to the main. It's typically about 1 to 2 feet. From there into the house is what we define as the service line. Typically at the property boundary, under or near the sidewalk, there's a curb stop installed on the service line, and a service dial box is installed over the curb stop, so there's easy access or shut off in some cases. Ownership of these lines vary by some system. In some systems, the utility may own the other line, the entire line from the main to the house. In others, the customers may own from the curb stop or where the property boundary is into their house, while the utility owns from the property boundary or the curb stop to the main. And that's the most common from what I've seen. That's often referred to as the public side and the private side, which you may hear me refer to throughout the presentation. So now that we've gotten the service line components straight, I want to dig a little bit deeper into the lead service line definitions in the new rule. Generally speaking, the service line is defined as the pipe between the water main and the building inlet. However, for inventory and replacement purposes, this is how we're understanding the different material definitions. So there's 4 categories. A lead service line is defined as a lead pipe anywhere between the connector and the interior plumbing. So this is not including a lead gooseneck or connector. A lead status unknown service line is an unknown pipe material anywhere between the connector and the interior plumbing. Again, this does not include the connector or pigtail. A new category in this new rule is the galvanized requiring replacement. This is a galvanized service line that is currently or ever was downstream of a lead service line. And one clarification here, that is a lead service line as defined here. So that is not including a lead pigtail or gooseneck. And then finally, we have the lead connectors here. So this is the goosenecks, pigtails with non-lead or galvanized pipe between the connector and the interior. So in what cases do replacing these count toward your replacement rates if you are triggered into replacement through an action level violation or action level exceedance? So the lead service line, this only counts if all of the lead is removed, public and private side. If you just remove the public side, that's not counted towards your rates. Lead status unknown, again, if all lead is found and removed, or if you determine that there is a non-lead pipe. If you remove a galvanized line and any preceding lead, that counts as a replacement for the galvanized requiring replacement. However, replacing just the lead connectors does not count towards the replacement rate because, again, these are not defined as the lead service lines. However, if you come into contact with if you discover any lead connectors, you are required to replace them as a matter of course through your work. And in all of these cases, including the lead connectors, public education is required if these are disturbed, which I'll cover in a later part of the presentation. All right, so we've come to our first poll. So I want to see how many known lead service lines are in your system. So if you have none, if you know that you've got 0 to 500, 500 to 2,000, or 2,000 or more. So we'll give folks a moment to respond to that.
And while we're waiting for answers to come in, I have a question here. Do schools built after the 2014 Reduction of Lead in Drinking Water Act effective date require sampling as part of this rule?
So that's a good question, and the answer is no. If you have a brand new school that was constructed after the 2014 date, or if all of the plumbing in a school was replaced, including the service line, was replaced after 2014, you do not have to sample that school or facility.
Great, thank you. Eric, how are we looking with the poll? Do we have all of our answers in?
Yeah, we have a good percentage here, so I'm going to go ahead and close that, and then I'll show the results. Okay, so it looks like we have none at 50%, 1 to 500 is at 40%, and then 10% are 500 to 2,000.
All right, so not so many lead service lines. That's Good. All right. So the first area I want to talk about with this is the lead service line inventories that are required. Under the final rule revisions, all systems must prepare publicly accessible inventory of lead service lines and service lines of unknown materials, or demonstrate the absence of lead service lines by historical record or physical examination. So the goal of this is to improve the system's ability to inform the public about the potential risks of lead and allow customers to take action to better protect themselves and their families. The actual format of the inventory itself is flexible. It can be a list, a table, or a map. It does need to include some sort of location identifier. This doesn't necessarily have to be the exact address, but it does need to have cross streets, something that your customers can look at it and understand if their house has a lead service line, or for example, a renter. So an example on the left is from the Greater Cincinnati Waterworks website. These colors aren't mandated. These are just what was used in this situation, but you can see it has it separated by the public side and the private side, coded as to lead, galvanized requiring replacement, non-lead, and lead status unknown. So the inventory does need to specify if the material is lead, non-lead, or unknown on both the utility and the customer-owned portions of the service. It's a little hard to see on the screenshot, but we've got the green for the galvanized requiring replacement, and then there's a difference between the lead status unknown and the lead. I also want to point out that while it's not required to list the specific material of non-lead service lines to be identified, such as if it's plastic or copper, it's recommended if you're going to verify these anyway, just to help with your general communication to your customers and your records for better capital planning. The inventory is required to be publicly available, and this must be online for systems serving more than 50,000 people. So on your website, it needs to be regularly updated, and based on the current delayed implementation, this is expected again to be September 16, 2024. Systems have to submit an updated inventory annually or triennially based on tap sampling frequency. If you do exceed the action level and you are required to sample every 6 months, you still only have to submit this annually. You don't need to do it every 6 months. If you have no lead lines in your system, so quite a few based on the poll, you do still need to create a service line inventory and make that publicly available so folks can check that out and see that they don't have a lead service line. And provide an explanation as to why your service lines are non-lead. However, you do not have to submit updates if you have no remaining lead service lines. Once your inventory is complete, you must notify all customers who have lead galvanized requiring replacement or lead status unknown within 30 days of publication of the inventory, and annually thereafter until the lead or galvanized requiring replacement is replaced, or until their service line is determined as non-lead. So this is a lot of notification around lead service lines, especially for those of you who have quite a few lead service lines remaining in your system. You must also include instructions for accessing the inventory on your consumer confidence report. So an example would be a link at the bottom of your consumer confidence report, or a QR code that goes directly to your inventory. So what information can you use to start your inventory if you're starting from scratch? If you already have some good materials identification from doing excavations or potholing, that's a great start. Other sources are water system records, including tap cards, distribution system maps and drawings, historical records on each service connection, meter installation records, historical capital planning improvement or master plans, and standard operating procedures. So you can look through all of those and try to get an idea of what you have where. Inspections and records of the distribution system that indicate the material composition of the service connections that connect a structure to the distribution system. Plumbing codes and permits and records in the files of the building department can actually help with this too. Sometimes they indicate service line materials that were used to connect to the water system. And we've even found that tax records can be a useful source. You can look at the home age, especially if you know when plumbing ordinances were in place that allowed certain materials or where lead installation was banned in your area. And as I mentioned earlier, systems do need to update the inventories annually. This can be done using the information collected if you're doing water main repair replacements, when reading or replacing your water meters, or if you have maintenance activities inside the homes. If you are doing water quality or find and fix assessments inside a home, you can go in and check out any materials that are visible, or through physical inspection inside the home when possible. If there's a requested sampling or information reporting by the customer. There are many informative brochures and videos that customers can use to identify their pipe materials, like scratch tests or swabs. Alternatively, this could be done by the utility at any time they're in the home. In all these cases, this could be recorded on paper and then used to update the inventory. However, we've been working with a lot of communities to document materials on an app, like we show here on the right. And in many times that can be uploaded directly to a GIS mapping system. So everything is updated real time. Another way is to ask customers to identify the service line themselves. There's, like I mentioned, there's the scratch test and the swabs that may or may not be allowed by the state. The rule does allow some flexibility with what the state will allow in terms of verification of records. So that's something to check out before you broadly implement customer verification of lines. The last category is predictive models. These can assess the probability of lead and can be useful for meeting full lead service line replacement goals if you're triggered into replacement and reducing the cost of exploratory excavations. If your system has any number of lead service lines, galvanized requiring replacement, or lead status unknown service lines, you must also develop a full lead service line replacement plan and submit that at the same time as the inventory, which right now, again, is anticipated to be September 16, 2024. The lead service line goal rate, that is something that's agreed upon with your primacy agency, so OEPA. Keep in mind before submitting that plan, right before the deadline with no interaction with the state is not feasible. So you want to get the communication going sooner than that. And also your EPA regional administrator may step in and adjust the rate, including setting a higher rate where they determine that it's feasible, even after the states have primacy. Procedures to conduct full lead service line replacements. So you want to know, how will you coordinate with your customers prior to replacement? Who is going to conduct the replacements? Are you going to hire a contractor, or are your crews going to go out and do these themselves? And how they will be completed. So there's a number of different methods for replacing lead service lines. So having a good idea of what will work in your system is good to know beforehand. Medium and large systems need to have generally a recommended lead service line replacement goal rate in the event that a trigger level is exceeded. And that has to be approved by the state. So this is especially important if you think your system might be at risk of exceeding the trigger level of 10 parts per billion. And there's a couple systems that are kind of hovering right below the 15 parts per billion. So they're not triggered any action under the current rule, but when this takes effect, you may be triggered into it. So it's good to know where you stand. Also, pitcher filter tracking and maintenance plan. You'll need procedures for flushing the service line and premise plumbing following replacement, such as high velocity flushing. That's where you open all the taps for about 30 minutes with the aerators removed. You'll also need a lead service line replacement prioritization strategy. So what are you going to target first? Those with verified lines, so the ones you know where they are, those who have the populations who are most sensitive to lead, or those in disadvantaged communities. Just have a general idea of where you want to start and why. And then finally, the funding strategy, specifically how you'll pay for the replacement of the utility-owned portion, and for customers who may not be able to replace the private portion of the lead service line, some opportunities that they will have to get help with their funding. So all of this must be submitted by that anticipated compliance date of September 16, 2024. So this is a lot in the next 3 years. So if you only have a few lead service lines, consider this an incentive to get them out. There are 3 other significant changes to the current rule. First, test outs are no longer allowed. So under the previous rule, systems that exceeded the lead action level and are required to conduct replacement could collect a sample directly from the lead service line. And if it came back at or below the action level, it was considered replaced through testing. This practice is no longer allowed under the new rule. Second, partial replacements are allowed only during emergencies or where the customer is unwilling, unable, or unresponsive as part of the infrastructure improvements. So a planned water main replacement. EPA is really discouraging this by not allowing partial replacements to count towards your goal or your mandatory replacement rates. So they're hoping that systems will make a good faith effort to coordinate with the property owners to reduce the amount of partial replacements in the system. They really want to get that whole lead service line out. If a partial service line replacement is completed, you do need to keep a record of the unreplaced portion in your publicly available inventory and continue to do outreach to those customers. Another change is the customer initiated replacement. So this means if the customer replaces the private portion of the lead service within the past 6 months, the system is responsible for replacing the public portion within 45 days of notification of the replacement. So the system can extend this to up to 180 days to account for weather or resource related limitations. For example, if they get notice in December and we're going into a hard winter, as long as they notify the state and you work with the primacy agency. Lastly, as mentioned earlier, water systems must replace the utility-owned lead goosenecks, pigtails, and connectors as they are encountered. So if you run into those little connectors at the water main, you are required to replace those. Now we'll discuss the lead service line replacement itself. So before any planned lead service line replacement, so not necessarily an emergency break, especially if replacing the public side, systems must notify residents and owners of the replacement of the work at least 45 days prior to the planned work. So quite a bit of advance notice here. You must also offer to replace, but you're not required to pay for the customer-owned portion. Several other activities that need to be completed when any replacement occurs for lead lines. The system has to provide education around potential for elevated lead risk mitigation, such as daily flushing and flushing procedures to remove particulate lead, high velocity flushing like we described earlier with that 30 minutes with all the taps open. They must also provide a pitcher, filter, and replacement cartridges for 6 months. And instructions for use immediately after replacement. So that's typically before the water is turned back on. Instructions on how to use the filter and replace the cartridges, and in the case of point of use devices or like the Brita filters that attach right to the faucet, instructions on how to install those. There are some slight differences in timing on these, but generally this must be completed again before the replacement is complete and before the water is turned back on. The only exception here is when the system learns that the customer initiated replacements where the system owned lead service line was left in place occurred within the last 6 months. Then you need to complete within 24 hours of notification from the customer. In addition to those, system must also offer to collect a follow-up tap sample between 3 and 6 months after completion and provide results to the consumer. The tap sampling protocol for this follow-up sample is up to the system to determine. So this doesn't, again, have to be that first draw compliance sample. Following, you should update your inventory, and in the case of full replacements, you need to update your sampling pool if needed, if that was a site that was included in your sampling pool. So we talked about the specifics, but now we're going to talk about when a full replacement is actually required. Excuse me. So I tried to put this together in the flow chart here. I'll discuss the 90th percentile calculation in a few minutes, but if your 90th percentile lead level in a given monitoring period is below the 10 parts per billion trigger level, you will need to continue customer-initiated routine lead service line replacements and the associated outreach and education to the customers. If you are above the trigger level, but below the action level, then you must implement full lead service line replacements according to the goal rate that you establish with the state in your plan. You must continue to replace at this goal rate until you are below the trigger level for 2 monitoring rounds. If subsequent 90th percentile results are below the trigger level for 2 rounds, so that's 2 years since it's required annually after a trigger level exceedance, then you can stop. If not, you keep going at that same rate. If the 90th percentile also exceeds the action level, then you must implement the full lead service line replacement at the 3% per year, and that's based on a 2-year rolling average. So that means you could complete 2% in the first year and 4% in the subsequent year, as long as it averages out to 3%. If your subsequent 90th percentile are below the trigger level for 4 rounds, so that would be 2 years because it's required semi-annually after an action level exceedance, then you can stop. If not, then you keep going. In the case of an action level exceedance, community water systems serving 10,000 or less, so small systems, non-transient, non-community water systems may choose their compliance option, and we'll talk about that a little bit later. However, if full lead service line replacement is selected, then the lead service line replacement must be completed within 15 years of all the service lines in the system. So if you exceed the action level, you're still required to conduct public education similar to the existing rule. And now that would need to include specifics about your full lead service line replacement program. However, EPA also added specific outreach requirements when you exceed the trigger level, but not the action level. So based on the introduction of that trigger level, there's kind of a new category that's in between those two. So here we show the kind of the keys to the outreach requirement. That's timing, content, and delivery. So your timing, it has to be within 30 days of the monitoring period where you calculated the 90th percentile above the trigger level. The content of the notification has to be a lead service line replacement program information, as well as opportunities for replacement. And the delivery is to all lead service line customers. And this includes the galvanized requiring replacement and the lead service unknown. You can do this by mail or other approved state method. You have to do additional outreach if you fail to meet your lead service line replacement rate that has been agreed on between you and the state. So if you fail to meet this in the first year, you must conduct 1 additional activity. So additional certified mail, maybe participation in a town hall meeting, community event, or phone, text, email, or door hanger. If you continue to fail after the first year, conducting 1 activity from the list above, so the certified mail, town hall meeting, etc., and then an additional 2 activities, and that could be a social media campaign, newspaper, TV, or radio content, or visits by plumbers and contractors. So the last category related to replacement is about disturbances. So we already talked about the potential for disturbances to cause temporary spikes in lead. EPA has added specific requirements for specific disturbances shown here and broadly categorized them into a couple areas. So we've got minor, these are from water shutoffs or bypasses. And in these cases, you must provide education around potential for elevated lead and flushing procedure to remove particulate lead. And then there's a major disturbance, and this would be from the replacement of the water meter, the gooseneck, or the pigtail or connector. In some cases, you have provided some educational materials for minor disturbances, and as well as providing a picture within 6 months. Providing a picture with 6 months of replacement cartridges. This all needs to be provided to the customer before the water is turned back on. So now I'll switch over to the tap sampling. So we've had quite a few changes in the new rule around tap sampling. And the tiering is one of the biggest changes that I want to talk about here. As you can see, the EPA revised the tap sampling criteria to include 5 tiers. This gives priority to the highest risk lead sources. There's some differences between community and non-transient, non-community systems. I'm going to focus on community systems here for the purposes of this presentation. So tier 1 and tier 2, this is where we're focusing on the highest risk sites, single family structures and multifamily residences served by lead service lines. The next tier is brand new for this new rule. It includes the galvanized service that was connected to lead or ever was connected to lead. And there's a slight difference here for sampling, as the EPA also allows sampling for galvanized lines that are currently or known to be connected to a lead connector. So even though that doesn't count in your lead service line replacement, for sampling purposes, if it is currently connected to a lead gooseneck or pigtail, you can use that for sampling in tier 3. Tier 4 are now single family structures with copper pipes with leaded solder installed before the effective date of the state's lead ban. This is an expanded definition compared to the previous rule. It included copper with leaded solder installed between just 1983 and 1986. So this is a little bit bigger pool of sites. The last tier is tier 5, and that's representative samples where plumbing is similar to other sites throughout your distribution system. So to be very clear on this, you can only use sample sites of a lower tier, or in this case what I'm saying lower is the 3, 4, 5, if you have an insufficient number of sites for all higher tiers. So if you have lead service lines in your system, you are now only sampling at systems that are at sites that are served by a lead service line. So all tier 1 and tier 2. Moving over to the new protocol, the EPA did finalize modifications to the protocol with respect to a few action items here. So first, systems are not allowed to direct any customers or samplers to conduct pre-stagnation flushing or to remove or clean the aerators prior to collecting a sample. I know that this was standard practice in some cases to remove the aerator to get the sample. That is not allowed. There's also a requirement to use wide mouth bottles, specifically greater than 55 milliliters or 55 millimeters at the mouth. Initially, there was some confusion around here. A lot of utilities were measuring their bottles and coming up with about 50. EPA has clarified this and says that this 55 millimeters can be the outer diameter of the mouth. In addition, EPA has modified the sampling protocol for lead service line sites. Systems will need to collect the first 5 consecutive liters. So you'll analyze the first liter for copper and the 5th liter for lead. The 5th liter is intended to capture the water from the service line and is shown here on my graph on the right-hand side. Data has shown that collecting samples from the service line tend to result in a higher level of lead. So again, to be clear, this is for lead service line sites only. That's tier 1 and 2. While the EPA does view galvanized lines in tier 3 as lead service lines for inventory, disturbances, and replacements, it does not view them as lead service lines for sampling purposes. So a little bit of complexity here. For tier 3, 4, and 5 sites, you'll continue to just collect that first liter and analyze that for both lead and copper. I do want to take a minute here to stress the impact of these sampling requirements. Changing to all lead service line sampling locations and collecting the 5th liter sample is anticipated to impact a lot of systems with lead service lines, resulting in potentially a higher 90th percentile compared to current sampling protocols. And that could exceed the new trigger level of 10 parts per billion or even the action level of 15 parts per billion. In Michigan, up here where I am, they implemented a new sampling protocol a couple of years ago. And shifted to the 5th liter sampling. The data is publicly available on the state's website, and several communities found themselves over the action level after changing their sampling sites and protocol. Data shows about 25% of systems may exceed the 10 parts per billion trigger level that's in the new federal rule. But even then, not all systems had completed their compliance sampling when we looked at the data set. So estimates are even up to 40% of systems in Michigan may exceed the 10 parts per billion trigger level. So not an insignificant item here that we're talking about. This could have major impacts for a lot of systems, triggering you into some of the actions that we've already talked about into this presentation. It's really important to take a close look at your data, close look at your site, and try to understand where you'll fall. So briefly, I also want to talk about the compliance calculation. Many of you, I'm sure, are used to the 90th percentile calculation, but there's a couple strict instructions in the new rule for doing this. For a system where all compliance sites are tier 1 and 2, you're using all of the sites in your calculation. This is the same if you have only tier 3, 4, or 5. You use all the sites in your calculation. It gets a little more confusing if you have a mix. So if you have some tier 1 sites and some tier 4, as shown on the example on the right, it's a little bit different. You have to use you first use all the samples from just the tier 1 and tier 2, and then only the highest of the remaining tier sites until you have reached the required number of samples for your system. So as you can see here, we're using all of the tier 1 sites and then just the tier 4 sites with the highest lead results. Until we get to the required number of samples for this example, which is 10. Lastly, on sampling, this slide provides some dates on the sampling frequencies. And I did not update this slide based on the rule with the additional comment period. So this may be January 1, 2025. Again, it could stay as July 21. We're waiting on additional guidance on dates for implementation on that. So first off, systems with lead service lines are going to begin using the new sampling protocol and going back to standard 6-month monitoring on this date, whether it ends up being July 1 or January 1 on 2025. Systems without lead service lines can use grandfathered data. The EPA is also changing the criteria for reduced monitoring based on the 90th percentiles. So if your 90th percentile is above the action level for lead or copper, you're going back into the semi-annual monitoring. If lead is above the trigger level, but if both lead and copper are below the action levels, then you're conducting annual sampling. And if you're a small or medium-sized system and the lead is below the trigger level and the copper is below the action level, after 3 years, you can go down to the triennial sampling. So a lot of different paths you can take depending on your specific situation. Any system that demonstrates lead below 5 parts per billion and copper below 0.65 milligrams per liter after 2 6-month monitoring periods can go down to triennial sampling as well. So there's additional provisions that reduce copper monitoring in this rule. So if copper is not an issue in your system, that could be either reducing the number or frequency of sites. So that actually may throw your copper sampling off from your lead sampling, and your compliance schedules may no longer coincide. Lastly, systems that add a new source or make long-term change in treatment after they've done all the appropriate studies and have approval from the state to do so, they must return to the standard 6-month sampling to assess the levels in the system as part of those changes. All right, so I'm going to move on to the last major topic, which is around corrosion control treatment, and I'm going to launch into my last poll here. So does your system currently use corrosion control treatment? So this would be any kind of orthophosphate treatment or control using silicates.
And Gwen, I do have a question that came in, but I just wanted to check in real quick as far as timing. We are scheduled to wrap up with this session in about 10 minutes. So just wanted to to let you know.
Okay.
So the question that came in is, are we not required to have a list of lead service lines publicly available if our system does not exceed 50,000 customers?
No, every system with lead service lines needs to complete the inventory.
Okay, perfect. Thank you. And Eric, how is the poll going?
We're at 82%, so I think we'd like to see around 90 if I can. Okay, 86, and maybe one more person. I'm gonna close it in like 10 seconds.
Okay.
All right, I'll try to breeze through these last slides. My last section is corrosion control treatment and just some wrap ups. So I'll try to go quickly.
So I finished the poll here, and we have 79% that do use corrosion control and 21% that don't.
Okay. So next, I'm going to go through a couple flow charts that show some action items based on whether or not you use corrosion control treatment and then where your 90th percentile falls. So for determining whether or not a corrosion control study is required and optimizing corrosion control treatment, EPA opted for a BIND approach. And those bins are based on size, presence of lead service lines, and 90th percentile, and whether or not you currently have corrosion control treatment in place. So I've tried to summarize that on these two flow charts. There's different for large systems and small and medium systems. So we're going to start with large systems here. If you do have corrosion control, so most of those on the call, you have two different approaches depending if you're above the 5 parts per billion, which is the PQL level, and the trigger level of 10 parts per billion, and then whether you're at over the 10 parts per billion or the action level. So if you are below the trigger level and you have corrosion control treatment in place, the state might still require you to conduct a corrosion control treatment study, but that's at the discretion of the state. If you're above the trigger level or the action level, you are required to conduct a corrosion control treatment study and then move forward with installing the designated corrosion control treatment. If you don't have corrosion control treatment in place and you are above the 5 parts per billion, it depends on whether or not you have lead service lines in your system. If you don't have lead service lines in your system, it's important to note that lead service lines are not the only source of lead. So you are still recommended to, you are still required to recommend corrosion control treatment for your system because you have other materials in your system that are providing lead into the bulk water, and then go ahead with installing that designated corrosion control treatment. The state may require you to conduct a corrosion control treatment study as well. And if you do have those lead service lines and you're above the 5 parts per billion with no corrosion control treatment, you will definitely have to conduct a corrosion control treatment study and install corrosion control treatment. So for small and medium systems, this looks a little bit different. There's a little bit more flexibility. If you're a small and medium system, you have corrosion control treatment in place, but you are still above the action level or the trigger level, you are required to conduct a corrosion control treatment study and install the designated corrosion control treatment. If you don't already have corrosion control treatment in place, it depends on your level. If you're above the action level and you have lead service lines, you are conducting a corrosion control treatment system and installing corrosion control treatment. If you are above and you don't have lead service lines, the state may still require you to conduct a corrosion control treatment study and install corrosion control treatment. If you're in between the trigger and action level, you're going to be recommending corrosion control treatment and installing that. So the requirements for these corrosion control treatment studies are pretty strict. They're similar to the draft revisions that were available ahead of the rule, but there's a couple differences. First of all, a study must consider pH and alkalinity adjustment. You must also consider orthophosphate between 1 and 3. This study can be any of the following: a harvested loop study. You can consider coupons, corrosion coupons, if you don't have any lead lines. If you do have lead lines, you have to do a harvested material loop study. And there's a photo of this on the right for one that I'm currently running. Other options include a partial system test and an analogous system evaluation, and that's similar to the current rule. There's timeline for sampling requirements based on the bin that your system falls into and your 90th percentile results. So if you have more questions about this, please reach out. I'm going to keep going in the interest of time. There's also some flexibility for small systems. EPA recognized that small systems, specifically community water systems serving 10,000 or less, may not have the resources to conduct these studies. They'll need a little more flexibility, so they have a couple options on how to achieve compliance. This could include just implementing the corrosion control treatment, implementing and maintaining point of use filtration devices. That means not only do you have to give your customers point of use devices, you are responsible for maintaining them, or replacing all lead lines within your system within 15 years or less, or replacing all lead bearing materials within 1 year. So just a couple of final thoughts. I've got another poll in here. We want to launch that. Just about what you find most challenging about the new rule.
All right, so while we're waiting for those answers to come in, I will ask another question. So with all of the requirements, is there any like assistance or resources available as far as, you know, like developing those notification material templates or sampling? I know that you mentioned training, you know, people outside of your organization. Are there any resources available to help with that?
Yeah, so unfortunately, there hasn't been a lot of published guidance from the EPA at this time. The primacy packages haven't been due yet, so a lot of the states haven't developed those materials either. We are really hoping that a lot of those come out, and I know that there's been a lot of comments to the EPA on the need for guidance. There's still a lot of clarification needed on the rule in this. There's so much in the rule, there's so much detail, and guidance is definitely needed. So unfortunately, there haven't been a lot of published guidance documents yet, but those are expected as we move through the implementation timeline.
Okay, thank you. Eric, are we all set with the poll? There we go.
Yeah, right here we have the answers. Looks like 25% sampling requirements or protocols. 10% think there's gonna be trouble with public notice requirements. 35% lead service line inventories, that's a big one. And then 30% on the last, lead service line replacement.
Okay, so a pretty big spread. So, you know, these different items are going to be challenging for different systems based on your circumstances. So whatever you're looking at, it's a good idea to get started now. So I'm just throwing up this timeline again, and I'll go through this quickly. But I think the answer, or the main point here is don't wait. We only have 3 years to get this into place, or around 3 years to get this into place. And there's a lot that you can do ahead of time. You can work on developing your improved service line inventory, start thinking about your path to achieve full lead service line replacements. If you only have, you know, less than 100 in your system, just get them out. You can, you know, work on doing that in the next couple of years and move toward that. If you have your lead service lines, if you do have lead service lines in your system, estimate what you think your 90th percentile might be. Take a good hard look at your data and see how many sites you have with lead service lines and how many of those are going to change. It's also never too early to start a corrosion control treatment study, because once you exceed the action level, you are going to be triggered into that for a harvested loop study, and that has to be constructed within 1 year. Give some thought to your schools and licensed daycares. Try to figure out what that means, where you're located, what the licensing means, and how many of those you're going to be anticipated to sample, and prepare for that rapid notification, because those 24-hour turnarounds are going to be really tough. So all those templates that you're going to be creating and education materials, have those ready to go. So just revisiting the learning objectives really quickly, and I think I'm at my time. So if you have any additional questions, please don't hesitate to reach out. Like I said, the rule is quite complicated and there's a lot in it. So I'd be happy to take any questions through email or phone and try to get you pointed in the right direction.
Thank you so much, Gwen, for your presentation. Sounds really interesting how we have all these new things coming into play, and it's good to see that there's really some, these issues are being addressed. Now with this, I'd like to let everyone know we're going to take a 5-minute break. So we will return about 1:16. And I'd just like to note for everyone that don't log out of the webinar, and please keep the webinar up as your main screen. We don't want anything to impact your potential score so that you can get your contact hours. So as mentioned before, we'll return here about 1:16 to get started with our next presentation. Thanks. All right, everyone, I think we're going to move on to our second presenter here to keep the event going along. So our second speaker today is Peter Latta. He earned his Bachelor of Science degree in Construction Engineering Technology from the University of Toledo, as well as his Associate of Applied Science in Architectural Technology. Pete assists in many aspects of project funding, identifying of project needs, and creative solutions. As the Toledo Office Director, Peter is a resource for problem solving across all disciplines and aspects of the business. As project manager and engineer, Pete leads a team in providing a hands-on management approach with experience ranging from water and wastewater treatment to pumping stations. Peter has extensive experience with field construction and brings a critical eye to development and design documents. With that, I've made you the presenter and everything should be ready to go.
Can everybody see my screen now?
Yep, everything looks good.
All right, thank you. Today we're going to talk about the Carey wastewater treatment plant. Perhaps one of the biggest things that we'll talk about with this plant renovation is it's not so much a renovation as it is a replacement. So kind of the introductory summary of what we're going to talk about today is I'm going to introduce you to the plant first of all, so you get a little bit of sense of the history, what the previous wastewater plant looked like, and how that led into what we ended up developing for the village with regard to their replacement versus rehabilitation. And then I'll go over an overview of all of the unit processes and what was entailed in the project. If time allows, we'll go into some of the design and construction challenges. And I got a lot of photos in here, so I will make, excuse me, an editorial note. In here, you will see all of the various names of the equipment, and I did that so that we don't get a lot of questions on, well, what piece of equipment did you use here and there? I'm not plugging this equipment in any way. I'm just simply letting everybody know what was used on this project. It was openly competitively bid. So in case the questions come up, you'll see in here what equipment was used, and you'll know that answer. So here's a picture of the existing, well, now replaced and gone wastewater treatment plant for the village of Carey. So the big debate that came up with when we first started this project with the village was, do we rehabilitate or do we replace it? And that's where everything started. You know, as with everybody, they always look at it and say, well, it's, you know, we've already got an existing facility. It's easier to just rehabilitate. It saves money, it saves time, and everything like that. So we go through the whole analysis of that, and I'll walk you through kind of that process. So a brief history of the wastewater plant. As we see here in this timeline, the original plant was built in '38, and that included the lab, administration offices, the screening and pump station, the grit facility, and aeration tanks 1, 2, and 3. And at the time, the chlorination and digesters. So in '61, they did a plant modification, added a clarifier, another digester. In '88, excuse me, they added aeration tanks 4 and 5, which increased the capacity of the plant. They added the EQ basin as well at that time, along with the effluent pump station and the tertiary ponds on the other side of the creek. And that'll be kind of a discussion point later on in the presentation here. So in 2001, you know, we kind of came in and did some hydraulic modifications to the plant. Basically, we put in step feed, trying to enhance the performance of the plant, try to, you know, just bolster it and be able to process as much of the flow as we could. And then in 2005, kind of focused on the solids aspect of the plant, rehabilitating, adding a belt press, rehabilitating the digesters, converting them to aerobic instead of anaerobic, and did some electrical upgrades, adding the belt press, etc. So So what are some of the challenges as we talk about rehabilitation versus replacement? What were the challenges with the existing plant? So one of them is the hydraulic capacity of the plant was very limited. They could only push about 2 MGD through the wet stream. Flow equalization was constructed, as I said, part of the 88 improvements. And then step feed around 2001 is what all contributed to the plant having an ultimate capacity of around 3 MGD. That's 2 through the main plant and 1 through the EQ basin. And then the EQ basin had a high flow overflow that it would occasionally relieve and go through the tertiary ponds. But that was perhaps one of the biggest concerns that the village had, was the hydraulic capacity of the plant. And the plant, when we evaluated it, was really limited. There really was no other way to expand the hydraulic capacity short of what was done in 2001 by adding step feed. So there really was a significant bottleneck in the system with this. So some of the other challenges that we had with rehabilitation of the plant, and this was a pretty significant one, is site flooding. During wet weather, the plant site would frequently flood, and I'll show you some pictures later on that you'll kind of get a better sense of what the flooding meant. But it would flood to the point that it actually would consume some of the tankage, therefore affecting the actual ability of the plant to treat. So, another significant concern the village had was just the age of the existing wastewater plant. As I mentioned, the existing plant was built in '38. So much of the tankage and stuff was old with regard to concrete and the structural integrity of the system. Some of that was pushing nearly 80 years old. The operators were concerned with regard to treatment capacity, reliability, ability to continue operating over the next 20 years. Much of the equipment in the plant was already 20 years old. Even some of the most recent improvements, the EQ basin of 88 was pushing 30 years old. So the plant was just starting to reach the end of its useful life with a lot of just tankage as well as equipment. And that's perhaps one of the key things that came into the discussion was, if you replace the equipment, that's one thing. You can get a new 20-year life, but you're not replacing the tankage. And if the tankage is 80 years old, 20 more years, it's now 100 years old. You're not starting that life cycle analysis back over. And I'll make a key point on that later on and show you what effect that has. So although the plant was operational, there were concerns with the plant's ability just to provide reliable treatment and meeting permit. And when you started to look at some of treatment requirements that were coming down the line, specifically phosphorus, the age of the plant and the technology that this plant had was questionable about meeting current limits, let alone potential future limits that were essentially unknown at this point, except phosphorus. So here's a picture of the existing facility. In the foreground, you see the 2 large ovals there. Those are the EQ basins. Just to the right of that is a little small building. That was the blower building for the EQ basins. In the background on the left-hand side of your picture, you'll see the large tertiary ponds on the other side of the creek. Because they're on the other side of the creek, all of their effluent was pumped across. And as a result, all flow was pumped a second time, essentially. And then the effluent flume and discharge was on the opposite side of the stream from the wastewater plant. So it's kind of difficult to see in the background of the picture there, but at the very far end, there's 2 circles. Those are the digesters, and then in front of that is the old original plant, which is the aeration tanks. So I'll kind of walk you through a few pictures. Here's a picture of the existing influent screen. This is the headworks of the plant, the original plant. You can see the comminutor in the background. just very aged, very deteriorated, not well screened. And I'll make a point of that here later on. You can see the bucket sitting there where they're constantly pulling in organics out of the flow stream. That screen channel on this picture here is on the left-hand side, so it was actually under the lab building. So the Headworth building was all integral, it was all common. This is a kind of a common design back in the 30s, but it was under the laboratory building. So, that doesn't meet current standards, current regulations with regard to hazardous environments and explosion-proof requirements. The pumps were in the basement, the raw pumps. So repair and maintenance on those was difficult at times. And then, as you can see in the drawing here, the laboratory was up on the first floor, which is ground floor level. So here's the back side of the laboratory building. This picture shows the existing grit equipment, and I've been working with the Village of Carey for over 20 years, and I can't remember this equipment being functional. So it has been non-functional for at least 10 years or more. But grit was important to them, but it just kind of shows you the age and deterioration level of some of this equipment. Again, this is the EQ basin. You can see the cracking in the concrete in the background there. The inconsistency in the aeration, that's partly due to the buildup of grit in the tank, in the EQ basin. There's weeds growing in the cracks of the concrete and stuff like that. So just again goes to exemplify the age and deterioration. This photo here is a picture of the existing blower building, which feeds the aeration. So these are the three large main blowers. It's an open-sided building. The air piping is going vertical, and then it goes out and goes underground. I'll show you a picture of that here in a minute. In the background of this picture, you can kind of see a little bit of the electrical gear back there, which this is what that electrical gear looks like. Being out in the elements, the system and this equipment is just aged. It's deteriorated. They've had failures with it. They've done a number of bucket replacements. It's been expanded, as you can see on the left side of the picture. Those couple of switches are much newer than the originals. And again, this equipment dates back to part of the original plant. So these here are the air lines coming down on the left-hand side of the picture. And you think what you're looking at is a mud puddle, but you can see all the little dimples. What that is the air bleeding out of the air lines underground and actually bubbling up through the dirt and through the soil and erupting. The moisture and water there is just groundwater, and the air just tends to rise up. They can never get this area to dry up, nor can they get it to quit bubbling. The seals have all been replaced on the pipe. They've done it a number of times, and it's just wore out. So here, this is a picture of the aeration tanks. In the background on the left-hand side, you can see double pitched roof building. That's the chlorine contact tank. The blower building we were just talking about a minute ago is the pink building that's in the background there. Again, you just kind of see the age of the aeration tanks. The light pole there is quite rusted. So just, again, kind of exemplifying what the plant looks like so you guys can kind of understand where the facility was at the time. In the left-hand picture in the foreground, you can see some deteriorated concrete. The concrete was starting to spall. These pictures don't quite do it justice as to the level of deterioration on some of the equipment and the concrete here. And again, these tanks are original to the plant. So these are 1938 facilities. So they're pushing 80 years old at the time. And I'll make a note here. So I talked about the flooding of the plant a little bit ago. On the right-hand side, you see another picture of the aeration tank. Now this would be aeration tanks 4 and 5, which are the newer ones, but you can see there's concrete deterioration. The ground, as it's sloping back away from this aeration tank, so from the front of the picture to the back of the picture, you can see a little structure back there. They all sit slightly lower than these aeration tanks. So while the aeration tanks never flooded due to the site flooding, this structure in the background and the clarifier immediately behind this aeration tank certainly did flood and frequently would flood and become overwhelmed. So the floodwaters would actually get into that clarifier, and as you can imagine, it just provided no level of treatment. That is a pump station in the background, the square structure with the two pipes sticking up. That too would flood out, and obviously the pumps are submersible, they would pump, but you're getting creek water and floodwaters into that pump station. Here's another pump station. This is the return sludge pump station. On the left-hand side is kind of an overall site view. And again, this pump station would frequently flood. On the right-hand side, you can kind of see the age and deterioration of the equipment, the pump supports and the conduits and stuff there, just starting to corrode away. This picture here shows a picture of the original digesters. They were, again, anaerobic at one time. The covers were removed and they were converted to aerobic. This building is a 3-story building here, where this is the main floor. The top up above is access to the top of the aerobic digesters, but there's a basement down below. Here being a picture of the stair access, and this is rather telling as well. You see the sandbags in the pictures, and those are there for the obvious reasons. The site floods. And when it floods, all of the digester pumps and their waste sludge pumps are in this basement of the digester building. Obviously, when the floodwaters come, it just rolls down the stairways, floods the basement, and renders the pumps inoperable. So the sandbags are there to keep the floodwaters at bay. Again, the left-hand side is kind of a good picture, standing up on top of the digesters. You can see in the background of this picture, the wastewater plant, a little bit closer view than the aerials. More importantly, in the front is the digester. You can start to see the concrete deterioration, the staining of the rebar rust on the right-hand side of the left picture. And again, just some concrete deterioration on the right-hand side picture of the digesters. This next picture is perhaps one of my favorite. It'll kind of come into play here in a little bit too. But as I mentioned in the first photo, the headworks and the screening of the existing plant was not that great. And here's an example of what happens when you don't have good headworks in a wastewater plant. These piles laying on the roof in the front next to the ventilators, and there's one in the background right at the edge by the handrail. These are inorganics, which make it past the screening process. Now, this digester is obviously the back end of the wastewater plant. It's the end of the process. So those inorganic materials are making it all the way through the entire treatment train and ending up in the solid stream in the digesters. So it goes through all of the pumps. It goes through all of the treatment processes, which is not good on all of that equipment. And they frequently have to skim these out of the digesters. This picture here on the left-hand side is an example of the inside of the blower building. These are the blowers that are feeding the digesters with the electrical gear. Just goes to show you the confinement of the space that the village worked within. Picture on the left-hand side is just from a different angle. The blowers are just out of the screenshot. So here we'll come up to poll question number 1.
So considering the difficulties and challenges that we've noted, how does your facility compare? You have the choices between worser than, similar, better than, and we have a new facility.
Okay, and while we are waiting for the answers to come in for the poll, Pete, I do have a question.
Sure.
So was there like a specific tipping point? It seems like there were a lot of things, but what was it that convinced Carey that they finally needed a new plant instead of, you know, fixing things as they were going?
You know, there was a number of things, as you point out. And as I kind of get into the analysis here in a few minutes, you'll kind of see how the dollars worked out. But I think the tipping point really for the village was the fact that you could replace the equipment and get a new 20-year life, but unless you replace the tankage was still 80 years old, and in 20 more years, at the end of the useful life of the new equipment, your tankage is now 100 years old. Mm-hmm. So I think that was really the tipping point. The other thing was probably the flooding was a pretty significant issue for them. There was really no way to get the existing facility brought back up above flood levels.
Great, thank you. And it looks like we have our results in for the poll.
As you can see, 90% say that their positions are better than, and about 10% say similar.
Okay, good, good. So continuing on, that was actually a well-timed question. So as we start to talk about the rehabilitation versus the replacement, you know, when we looked at the rehabilitation, it did have an initial lower cost, as you can see in the table here. In other words, your capital investment up front, but it had a higher present worth value. And part of the reason for this is that when you take into account the age of the existing tankage, it had no useful remaining life. Therefore, in the analysis, you're looking at a zero salvage value on it. And again, the new facility would have remaining useful life on the present worth analysis, thus on the present worth, making it a much lower cost. So we got into the discussion quite extensively about rehabilitation versus replacement. And again, going back, just, you know, the initial capital cost on both these options are relatively close. I mean, we're talking $7 to versus $9 million. So, you know, it was a very serious discussion about is the extra $2 million worth it? And that's what the discussion came down to is, why did ultimately the village commit to the replacement of the facility? And again, it goes back to that design life of 50 years on the tankage. And as we all know, wastewater facilities typically keep things way more than the 50-year design life, Carey included. I mean, they had tankage that were 80 years old. You know, after the debt retirement, there was salvage life or service life remaining on the tankage. Design life of equipment was 20 years. Another significant issue was the hydraulic capacity. They really wanted a facility that could handle their design flows all through the main wet stream with no flow equalization. So, and then they wanted to eliminate overflow events and bypasses. So all of the new facilities constructed above 100-year flood elevation, again, was a significant concern for them. This allows proper operation during flood events and increased reliability with regard to treatment. The existing plant had been worked on so many times that there was a lot of what do I want to say, modifications to the facilities. So, you know, working within a facility like that, there would be less conflicts with underground electrical, trying to rehabilitate the existing facility. So a new facility would be a much cleaner installation, much more efficient, and much easier to maintain going forward in the future. The other thing too is that the new plant would be able to adapt to future regulatory mandates and expand for economic development in the community if such an event was to occur. So these are all, you know, key considerations that the village took into account some of them more engineering analytics, but some of them just on the softer side. So the village makes the commitment to proceed with a new plant. What do they want to build? Well, the first things is Carey is not a CSO community. However, they do experience high flows due to excessive I&I in their collection system. Due to the hydraulic limitations of the plant, there were some challenges with trying to figure out how big of a plant to build with regard to the flows, because the plant where the sewer's backing up and giving the appearance of excessive flow because the plant didn't have capacity, or were the flows excessive, just well in excess of what the plant could handle. So it becomes a little tricky when you try to analyze that in order to determine a sizing of a plant. So what the new plant ultimately we came down to was, in the flow analysis, their annual average day currently at the time of the design was about 0.6 MGD. Their dry weather flow is down as low as 0.25 or 250,000 gallons a day. But their peak flows in our analysis was in excess of 3 million gallons a day, which is nearly a 10 times factor of dry weather to peak wet weather event. So through careful analysis and discussions with the village, what we ended up with was, obviously their plant is a basis of design is 0.9 based on their NPDES permit. So we stayed with that. That was well within the average of the 0.6, and their dry weather is 0.25. That's okay. But the 24-hour peak that we ended up settling on was about 5 million gallons. On the left-hand side of the screen, you can see they're very typical characteristics. Their influent BOD, we designed for a 200. I think they were coming in around 150s, 180s. So it varied from time to time. So, and a key note here too, their alkalinity is a little high, and I'll explain why that's important a little bit later. And the EPA came back after several meetings, and basically we were going to get best available technology limits, which their effluent limits are there. For BOD and TSS, ammonias and phosphorus, the target was 1, with likely going to be seeing in a few years a 0.5. So I think those are very typical, but the key point is the flow. So what to build at the wastewater plant? So through the discussions with them, we got into, obviously fine screening was a concern, as you saw from the pictures of the existing digesters. Grit removal was a concern as well. They do have a lot of grit settling out in their tankage. The existing plant had a primary tank, and we think that was acting more like a grit tank. And then the oxidation ditch, and I'll go through each one of these as to why we went in and selected some of these. And then final clarifiers, UV disinfection. They wanted to get away from the chlorine, and some solids handling improvements as well. So as we start to walk through each of the unit processes, the headworks screening, why screening? Well, screening, as you can see from the pictures, they do have, they're mostly a gravity system, so they do get a lot of inorganics coming down. There are not a lot of pump stations in the system where that's the inorganics and organics and stuff get ground up and macerated in order to pass through the plant a little easier. The other thing too with screening, the village hasn't had good screening or grinding in quite a long time, and it was creating havoc on the plant. It protects a lot of the downstream equipment when you have screening. So screening is extremely important. It also cleans up your sludge on the back side of things. The village of Carey goes to landfill, but if you're still doing land application, screening is extremely important there as well. The other key thing is that they were putting in a grit system, and a grit system will perform much better if you can try to get that organic material out of the way, and it helps the performance of the grit system. So here's a 3D image of the headworks building where we had the screening involved. On the left-hand side, you'll see the long pipe coming into the left side of the building, and the screen is there, kind of sit on an angle, and that is the main screen channel. The sewers come in about 12 feet deep. It's 36-inch sewer. There are 2 different sewers combining on the plant site. But we mechanically clean the bar screen. It's a 1/4-inch bar spacing. The mechanical screen is designed for a 5 MGD capacity, approximately a 3.4 feet per second, with a head differential around 3.5 feet at 25% blinding. So there is a bypass channel with gate controls. The bypass channel sits right behind in the picture, but right behind the screen. The mechanical screen did have a washer compactor and discharges up into a dumpster. The washer compactors are very important. It tends to wash all of the organics out of the inorganics and separate them well. And the organics are then deposited right back in through the drain into the flow channel to process for treatment. So, and then the inorganics are dumped into a dumpster and hauled to landfill with their other solids. The left-hand side of the picture, you can see the basement of the building is where the pumps are, both return and waste sludge, and then on the other side are the primary pumps for influent flow. And on the first floor is the electric room. So headworks pumping was extremely important on this project. We have split the flow into 2 categories. We call them dry weather flow and wet weather flow. The reason for this is I'll go through here in a second. So the dry weather flow pumps are handling anything from, well, 0, but 0.2 MGD up to 1.2 MGD, operated on a VFD, and they're variable flow. And all of that flow, so up to 1.2 MGD, is pumped up through the grit system. And from the grit system, it then flows over to the BNR and then over into the oxidation ditch. The reason for this is that it catches that first flush of flow coming down, which is where typically a lot of your grit will come in at. And I'll touch on that here in a minute. The wet weather flow then is in essence like step feed, as we talked about previously with the existing plant and as a lot of other conventional plants will have. It handles the flow from about 1 MGD up to 3.8. And that is run in combination with the dry weather flow. So the first 1.2 MGD always goes up through grit, and anything in excess of 1.2 is then pumped through the wet weather flow pumps over to the oxidation ditch directly. And it bypasses the grit and the anaerobic tank. So, and again, it's very similar to a step feed arrangement in a plant. So here's where the headworks pumping discharges. So the picture on the left-hand side is where the wet weather pumps are being discharged. That's a flow channel sitting across the oxidation ditch. In the foreground is the outer ring, and in the background is the inner ring. And typically the wet weather will go to the inner ring, again, as that step feed type process. On the left-hand side picture, you'll see it's actually standing up on that flow channel on the left-hand side, but you're looking backwards at the anaerobic tank, and the grit is kind of in the background there behind that crane. And the flow, so the flow from the grit comes up into the grit channel, into the anaerobic tank, and then flows into the outer ring of the oxidation ditch. So why grit removal? Number one, this is where the village was really integral in the whole design process. They were really engaged, and I encourage other owners to be very engaged with your design professionals, because you guys really bring forth a greater knowledge than what we have. You know, we can dig into the mechanics and the nuts and bolts of a plant, but you guys have the experience with operating it. And the village of Carey knew they had a grit problem, and so they really pushed to have grit in this facility. They have older sewers that are, you know, allowing a lot of deposits and a lot of grit to come in. They experienced the deposits in the primary tank and in the EQ basin from before. So here, you know, on the left-hand side, you can see the grit system that we have installed, and it's a vortex-style grit system. You know, we did it to initially right up front in the plant in order to help protect a lot of the downstream equipment. Again, the grit removal in this picture here, you can kind of see right in the dead center, there's a round circular tankage there. That is the actual grit concentrator. So the flow comes into that, the grit concentrates, and the velocities in the water changes and the grit drops to the bottom. Flow rises up and goes to the right-hand side of the picture into that open tank, which is the anaerobic tank. So that's kind of how the grit system, and then on the left-hand side, you can see the grit classifier. This picture here on the right-hand side, again, is the grit concentrator. Again, the flow kind of comes in, the little pipe on the right-hand side, swirls around inside of there, the grit drops to the bottom, and the flow comes out the top side of this, and the weir into the anaerobic tank is sitting right in front of us in the foreground of that picture. The left-hand side, again, this is just a picture of the grit pump. The pipe goes through the wall and connects into the bottom of the vortex, which is on the right-hand side. This is a picture of it in operation. You're kind of looking at it from a different angle, but the little circle there on the right-hand corner of the picture is actually that opening in the top of the concentrator, and that's the flow coming out of it, passing over the weir into the anaerobic tank. So this is a picture of the grit washer. Again, the grit is pumped out of the concentrator, pumps over here into another little vortex on top of the classifier. And again, it's just a separation of the liquid from the solids. The solids are conveyed up through a conveyor and dumped into a dumpster here. The liquids are then sent back into the process stream for recirculation. So here we're up to poll question number 2.
Does your community's wastewater treatment facility have biological phosphorus removal? And yes, no, or I don't know are the options.
And we'll go with another question while we're waiting for those responses to come in. Is there anything that you would point out as the biggest challenge of this project?
Yes, as with most projects, perhaps one of the most challenging things was the funding. You know, site flooding was a pretty big challenge. And as I'll kind of get into here, there was another challenge with regard to phosphorus treatment. Because as we got into the plant, we found their phosphorus was actually quite high. So that's the reason for my poll question, leading into some discussion on the biological treatment and phosphorus removal. So.
Eric, you're muted.
Yeah. Sorry about that. So we got a good amount here. Very even split, 30% at yes, 35 no, and 35 I don't know.
Okay, interesting. Good. So again, the reason for my poll question is because in Carey, you know, again, this is where having an active owner actively engaged and participating in the design process really helps a design professional deliver what is best for the village and for the operators at the facility. So what we did was we did some initial testing on phosphorus and discovered that their phosphorus comes in what I would say on a scale of high to low is relatively high. I mean, they're coming in at almost 9 milligram per liter. Some days are lower, some days are higher, but for the most part, they were coming in at 9. So that begged the question of, okay, how are we going to treat this? And it led into the question or the decision behind why we added biological nutrient removal to this plant. So another key factor in the treatment of phosphorus came into play was the alkalinity, which I had mentioned earlier. The alkalinity in Carey happened to be a little bit high, and as a result, we found that some alums, not all of them, but there are some alums that generally don't react well when the alkalinity is off. So we being the Jones and Henry as well as the village looked at this, and they decided that they wanted to go to iron salts, so ferrous and ferric chlorides and stuff like that, in order to treat for the phosphorus. Well, when we look at the phosphorus coming in at a 9 milligram per liter and the chemical dosing rate then had to be elevated in order to bring the phosphorus down to at least a 1, if not in the future a little below 1. Well, because the village wanted to stay with UV disinfection, the iron salts in high concentrations in a wastewater plant can lead to some fouling on the UV system, therefore affecting its operation. So we started to look at this and try to come up with some solutions, and one of the key solutions was, let's do biological nutrient removal. Number one, we know biological wasn't going to completely eliminate the chemical feed. However, what it would do is it could at least reduce the phosphorus coming in down to a significant enough level that it would reduce the chemical feed, therefore not presenting problems for the UV system downstream. So follow up to this, since the plant's been in operation, the BNR process actually has been able to get their phosphorus down to just about a 2 as of right now. They're still working to dial it in, but they're going from a 9 to 2 with the biological nutrient removal. So now what they're doing is they're polishing with chemical feed from the 2 down to 1, or in a future possibly a 0.5. So that significantly reduces that that chemical feed rate. So as we move on, again, talking about what we were deciding to build and what treatment processes were going to be, the secondary treatment process was going to be an oxidation ditch. Why an oxidation ditch? Well, again, the village wanted to eliminate the tertiary ponds. They also wanted to eliminate the EQ basin in order to simplify and streamline their entire treatment process. And of the processes we looked at, the oxidation ditch would perhaps be the most effective at that. An oxidation ditch is capable of a swing and flow of at least 10 times the dry weather flow, which we have. We swing from a dry weather flow of 250,000 a day up to almost 5 MGD. The oxidation ditch also includes an integral BNR process. It's a simplified wet stream process. Again, it incorporates the step feed for stormwater flow during high flow events, and also protects the BNR process to keep it functioning as well during those high flow events. And in integral is the denitrification to achieve reduction of nitrogen or nitrate and nitrogen. So again, it's kind of an all-in-one package where you can just do it all in one treatment train rather than having multiples. Let me back up. So in the picture there on the left-hand side, you can see the oxidation ditch, the inner and outer ring. In the top of the picture is what you can see, that closed-in concrete deck area. That is the anaerobic tank, and then right up against the building is the grit system. So it's kind of a small footprint when you think about the grit system, the anaerobic tank, and the oxidation ditch all sitting right there in that facility or in that footprint. So here's a right angle view of the oxidation ditch, as you can see in the background of this picture. As the flow moves from the oxidation ditch, it goes into a splitter box, which you can see kind of in the center of the picture there. The flow splitter box, all it does is split flow hydraulically. Allows them to control whether one clarifier is online or both. Typically both are online at most times, but for maintenance purposes, they can take one offline. The clarifiers are 45-foot clarifiers. Each one of them has a peak flow rate of 2 MGD. The two of them combined is what gets the 5 MGD at the plant. Solids loading rate for the clarifiers is 30 pounds per square foot per day. And then the overflow rate is the 800 gallons per day per square foot. And that's a little bit low, and that just goes along with the guidance due to the fact that they're feeding chemical and phosphorus removal potentially. So the loading rate is under, they tend to oversize clarifiers a little bit because of that. The clarifier, something the village is very fond of, and they've had on past clarifiers, is a brush system to keep the weirs and baffles clean. So they were very very enthusiastic to have that again. So from the clarifiers, we flow over to the UV system. Why UV disinfection? The village was not real keen on the safety requirements that comes along with chlorine. They're a relatively small facility. They're limited staffed. When they have to change chlorine cylinders, they need multiple staff on site. Sometimes they function on one operator, as the chief operator is dual between water and wastewater. So just the simplified operation with UV system. The other reason was the wide swings in flow. Again, we're seeing flows, peaking of 10 times. And a UV system is very conducive to those wide swings in flow, whereas chlorine feed systems are typically flow paced, and as the flow increases, you have to increase that feed rate. And by the same token, you can sometimes overfeed if your loading requirement in the effluent is not high, because you're seeing a high flow doesn't necessarily mean that your need for chlorine has gone up proportionally. So the bulbs vary intensity, which maximizes the efficiency and also provides redundancy. Some key considerations with the UV disinfection on a wastewater plant. Number one is an outdoor facility. I know some facilities like indoor enclosed facilities, but for a UV structure, it saves cost, and it also cuts down a lot on the nuisance insects. You get a lot of flies and insects floating around on the effluent side of a plant. And when you put a building up, what happens is those tend to grow and accumulate inside the building. It just becomes a nuisance. Another key thing here, you can see in the picture, the grading is off, running right down the center of the picture. Those are the two banks of the UV system. But this grading is actually not open grading, it's a closed grading. The reason for that is the UV gives off light, which is actually a safety issue. If you look into it, it's like looking into the arc welder. If you've ever had an arc flash or welder's flash. And then also on the other channels parallel to this in the picture on the left-hand side, you can see that the grading is again closed in. The reason for that is it cuts down on the algae growth, because the clean water and effluent structures typically will tend to grow some algae and stuff, which if you're doing your sampling downstream of that, the algae can actually lead to some bad samples. So, and then in the background, you can see the effluent sampler sitting there, and we draw effluent right at the structure as well then. So here's a picture of the flume, which is the other parallel channels in this structure. And then on the right-hand side of the picture is the long weir required to maintain level in the UV, because the UV needs to be submerged at all times. So as the flow varies, this weir allows a very slight fluctuation in the depth of flow, even though the flow increases substantially. And that keeps the submergence on the bulbs. So as we get downstream of the UV, we also moved the effluent point and the discharge point, which required some additional permitting and stuff. But was important because the village didn't want to pump wastewater flow back over to the other side of the creek to flow through the existing flume and meet their the existing discharge point. So they kind of wanted to abandon everything on the opposite side of the stream. So that's why the effluent was, or the discharge point was actually moved over to the same side of the creek as the wastewater plant. So as we got into some of the most recent improvements at the Village of Carey was the solids handling. So solids handling had been recently improved with regard to about 10-15 years ago. They had put in a sludge holding building where the belt press was located and a dry storage pad. So the belt press, although at the end of its useful life, the building and everything else was relatively new. So they wanted to maintain that, but they also wanted to continue with the solids handling process because the village hauls all of their waste sludge to landfill. So because of that, and they had no commitment to going back to land application, we ultimately reached an agreement that they only wanted to work with a solids holding tank rather than an actual digester. The reason for that is they go to landfill, so there's no reason to do volatile reduction. And with having a belt press, they're already concentrating their sludge in order to reduce volume for hauling to landfill. So the other thing that a solids sludge holding tank does is it creates a little more efficiency because you're not trying to achieve that volatile reduction. So there's some energy and cost savings there. This is just a picture of the decanter. We did set the sludge holding tank up with a decanter so they can decant clear liquid if needed. They can do a little bit of thickening in these tanks so that it goes to the press at a reasonable concentration. Again, pictures of the new blowers, blower for each side of the sludge holding tank, crossover piping, so they can run, typically they need to run one blower, but the second one's there for redundancy. So here we're up to poll question number 3. So we'll get that posted. And
how are the solids disposed of from your community's wastewater treatment facility? Select one of the below: land application, landfill, Class A compost, incineration, or you don't know.
And we did have a question come in. What is the cause of the high influent phosphorus?
That's a great question. We don't know that. In fact, we're working with them still today to try to source that out. They're starting to do some system-wide spot checking, looking upstream of the wastewater plant, trying to locate it. There is the potential that there could be some runoff from agricultural fields contributing. Again, no proof or evidence of that yet. That's all speculation. So yeah, they don't have a great industrial base where we'd see like a metal processor dumping a lot of phosphorus or anything like that. So again, that's what's challenging about it is they can't identify clearly a point source right now.
Okay, thank you. Hopefully they'll figure it out since they're looking into it.
Yes.
So we've got roughly 80% in. I'm just gonna go ahead and close it here because we've had it open for about 1.5 minutes now. So the answers that we've gotten are 33% land application, 56% go to landfill, 6% compost, and 6% do not.
Okay, so a good mix. So as I said, the Village of Carey was planning on continuing the land application process, and the existing belt press again was at the end of its useful life. So we investigated all lines of equipment. They didn't want to stick with a belt press because they were having challenges with that and a thinner sludge. So ultimately, we settled on a dewatering press, similar to a screw press, a volute press. So the operational problems with the thinner sludge kind of went away with a screw type press. And with replacing it, they were able to increase the capacity of the press to better match the plant. You know, the old plant, they were pulling solids out and probably not capturing as much solids because a lot of them were going over to the tertiary pond, and a lot of them were being captured in the EQ basin and being removed there. So, and they weren't treating for phosphorus, and phosphorus treatment can actually increase your load on your plant when you do chemical feed. So that was one of the key reasons for increasing the capacity of the press then. And the press, I should note that the press was actually installed in the place of the belt press in the existing facility. So it really was just kind of a swap out of the equipment. So these are the tertiary ponds. Again, this was an important feature to the village to abandon. They wanted these closed and abandoned. They wanted the sludge removed. And they were actually looking to recapture this land for other purposes within the village. So on the left-hand side is a aerial photo of the tertiary pond itself. On the right-hand side is the process of abandoning it. With the abandonment of the EQ basins, a lot of that soil was able to be hauled across the stream and dumped into the ponds, and we were able to balance a lot of the excavation out on this project. So that worked out really well. Project cost, the original engineer's estimate was $10 million. Bids came in at $10,813,000. The final project cost actually finished under budget, excluding sludge removal. The village kind of kept sludge removal separate on this project and kind of did it as a separate side. It was included in the project, but it was a separate side cost. So sludge removal ultimately amounted to about $1.5 million, but we have to give consideration to that they had not cleaned those ponds in the better part of 30 years. So there was a lot of sludge accumulation. But again, to the point too, that sludge accumulation was so much because the plant was underperforming and not performing like it should have been. How are we doing on time? About 5 more minutes or so. Design and construction challenges, flow conditions. The peaking factor was a key design thing. That comes into play also when you start to look at return sludge and waste sludge flow rates. It starts to get a little challenging trying to meet minimum flows and peak flows, resulting in multiple arrangements. Phosphorus removal was again a key element of this project. There were some challenges that were unique to Carey regarding the alkalinity, the downstream UV system with having to feed iron salts. So those were certainly a challenge on the project. The headworks building, something I didn't mention early on, but I want to mention is, and this is speaking directly to owners. And some of the other design professionals may know this, but this project had a lot of VFDs on it, and it's extremely important to consider a climate-controlled room when you're putting VFDs in. We're finding that VFDs are becoming more and more sensitive because they're more and more electronic, so they're very sensitive to heat fluctuations and air temperatures and stuff. So it's very important to consider HVAC, and I do mean air conditioning and electric room. So it seems a little overkill in a wastewater plant, but it's important for the level of instrumentation and process equipment that's being installed in some of them now. So, and again, the pump room in the basement was climately controlled as well, just more so from the recycling of air changes and stuff for humidity control and trying to maintain a good atmosphere down there to protect the pumps. Some other site challenges and stuff were, as I mentioned, the flooding was a huge thing, and relocation of the outfall. location of the new plant on the site. In other words, on the existing plant site. They didn't want to go across the creek from it. So that created some construction sequencing challenges. And I've had this question come up before. How did we handle excessive flow with the removal of the EQ basin during construction? Because as you can see here in this picture on the right-hand side, those two ovals in the center of the picture are the EQ basin, and that is where the oxidation dish sits. So yes, we took out the EQ basin, and the EPA was aware of it, and it took some discussion and negotiating with them, but at the end of the day, we were allowed to sequence the project and build the new plant over top of where the existing EQ basins were, which allowed the village to maintain that goal of keeping everything on one site. So again, there's the EQ basins in the demo state being removed, starting to haul some of the dirt away. Some more aerial photos, just again of the EQ basins. Again, picture of the before and after. So on the left-hand side is the before picture. Perhaps the key benchmark to put yourself in orientation is the long white building in the center of the picture on both pictures. That's the existing sludge handling building. So you can see where the new plant was really consumed the entire area of the existing EQ basin. So. And with that, I'll kind of end with a few thank yous. The Village of Carey, again, was very engaged in this project, very important, very integral. Mayor Rathburn attended a number of design meetings and was integral. We met with council a number of times. Nathan and Jim, Nathan Curtis was the administrator, and Jim Hunter was the superintendent of the plant. And Nathan kind of came in the middle of the project after Roy retired. So, and this was actually kind of a lifelong career thing for Roy. When he actually started as the superintendent and worked his way up to the administrator. So again, a very active and very engaged client, and it made the project very successful. And then a special thank you to Peterson Construction. They did the aerial photos because they did the construction of the project. So they provided the aerial photos for this. So with that, I guess if there's any questions, I can certainly answer them. I can be reached via email. If anybody has any questions after the presentation, feel free to reach out to me. I'm happy to talk to you.
Well, thank you so much, Pete, for your presentation. It's really fantastic to see really kind of the infrastructure changes that we have the ability to make at these different sites. So looking forward to see kind of how these projects can expand everywhere else that are around to really help out the needs of all these villages. Unfortunately, we won't have time for any more questions since we're kind of right up against our time limit, but thank you very much. I appreciate that. I'm going to switch over to showing everyone the final wrap up for this training session to make sure that we can allow everyone to get credit for being here today. So the first thing that I'd like to talk about is, in order for everyone to receive these operator credit hours, we look that you submit the TMACOG contact hour request form so that we can be able to get all that information to get you your certificates. The easiest way right now is using the GoToWebinar tooltip. I'll pull over what I have. So over on this section, you can actually see there's a handouts button. And when you click on that, there's a link to the PDF that you can then get and download. Then if you go through and fill that out and send it back to us, we can get you ready for your contact hours. As I was mentioning previously, TMACOG will provide contact hours to all attendees who met the minimum requirements as laid out previously. We'll also notify attendees via email and they will be provided with a certificate of attendance or for their qualified hours. We'll also upload all those qualified attendees to the OEPA website within 30 days. And I'd also like to remind everyone that there's the mandatory survey following the webinar, and that'll come up when you exit out, or if for some reason it doesn't, there'll be a follow-up email in an hour that will provide the survey link as well. One of the things I would also like to note is that in this slide here, I have, feel free to contact me with any questions you might have. And I have the contact hour information listed below with the OEPA course approval numbers. That will also be available in the email that will come out to you in an hour after the presentation or after the webinar ends. So I'd like to thank you very much to all of our presenters and to Jones and Henry for their sponsorship, and thank all of you for coming by for these, either just this session or all of the different ones we have. I really appreciate everyone taking the time to do this, and we here at TMACOG are very happy to help provide these opportunities to really increase engagement and really help you guys out as much as possible to be able to fulfill your credit hours. So thank you very much, everyone. I will be, as I said, when you close out, you'll have access to the survey, and feel free to take this time now to download that handout so you'll be able to easily have access to that form. So thank you, everyone, and I look forward to talking with everyone at another time.